Okay, for the first math, we are given a process Wt with the expectation of Wt is equal to 0. That means the mean does not depend on t. So if we shift t, the expectation will again be 0. So E of Wt minus 1 is also 0. So using that property, we can find the expectation of Yt would also be 0. And the autocorrelation of W in time t1 and t2 is alpha times the minimum of t1 and t2, so which is not a function of the difference t1 minus t2, so the process is not wide sense stationary. And for ry of t1 t2, we use the linear property of the expectation operator and expand yt, the multiplication of yt1 yt2, and we find four terms: E of Wt1 Wt2, E of Wt1 minus 1 Wt2 minus 1, minus E of Wt1 Wt2 minus 1, and minus E of Wt2 Wt1 minus 1, which is for t1 t2 greater than 0, and if it's less than 0, it's the autocorrelation would be 0. For the next math, which is a Poisson process n with parameter lambda, and if the time difference is again t1 t2, that time duration is t1 comma t2, then the Poisson process is the probability of the arrival equal to k is equal to e to the power minus lambda, the time difference t2 minus t1, and again lambda into t2 minus t1 to the power k divided by k factorial. And the next process is defined as x of t is equal to 2 and x of t is equal to minus 2 for the arrival to be odd and even respectively in the duration 0 to t. Now we use common formulas of e to the power x and e to the power minus x, and we find out that half of e to the power x minus e to the power minus x is equal to the odd parts, and half of e to the power x plus e to the power minus x is equal to these are the odd parts actually, 1 plus even parts, 1 plus x squared by 2 factorial plus x to the power 4 by 4 factorial, etc. Since arrival 0, that means x of 0 would be even, so x of 0 would be minus 2. So that using that hint, we draw the sketch as the xt starts from minus 2 and then it goes to plus 2 and minus 2 periodically. So now the probability of even arrival, or that means xt would be minus 2. The probability would be the summation of the Poisson processes, and we use the summation formula for even, and ultimately after some simple calculation we find out that it is e to the power minus lambda t cos hyperbolic of lambda t. And also the probability of odd arrival, which gets xt is equal to 2, will eventually be e to the power minus lambda t sine hyperbolic of lambda t. Since it's a discrete Poisson process, discrete process, so we can find the expectation by multiplying the probabilities with the values of xt, and that's how we find the e of xt is equal to minus 2 e to the power minus 2 lambda t. And now for the autocorrelation, we know the product of xt1 and xt2 would be positive if both of them are positive or both of them are negative. If one of them is positive and negative, the product would be negative. So using these hints, we can find out that rt1 t2 is equal to e of xt1 xt2, which is plus 2 multiplied by the probability of xt1 xt2 is equal to positive, which is 2, and minus 2 multiplied the probability of xt1 t2 is equal to negative, that's minus 2. I just rewrote that minus 2 part since it was not that clear previously. Then it's just simple algebraic process. we sum them up and find out the answer to be twice e to the power minus 2 lambda times the difference of t2 minus t1, so which is tau. So ultimately the autocorrelation depends on the difference of t2 and t1, so the process is wide sense stationary.